This video is an introduction to graphing sine and cosine. As we prepare to graph, it's helpful to keep in mind our unit circle and the special angles that we use to keep track of sine, cosine, and tangent. So, for example, starting here from 0, looking at the big picture, this is going to be 0. Of course here, well, let me skip all the way over to here first, because this halfway around is pi, alright? That's our basic unit here. So the upper semicircle is pi, so then halfway is going to be pi over 2, half of pi. And if I keep going in that way, I've got 1 pi over 2, 2 pi over 2, and this would be 3 pi over 2. And then this would circle back around, and on the return trip, I will think of this as 2 pi now. So I start at 0, all the way around, I'm at 2 pi. Now I can get into more detail if I go the next level and I cut this in half. Alright, so if I go 90 degrees, that's the same as pi over 2. But what about if I go halfway and I go 45 degrees? Well, that would be 1/4 of my whole pi here. So this would be pi over 4. And going around the circle at that level, this would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 2 pi is the same thing as 8 pi over 4. We could go into even more detail and do pi over 3 or pi over 6. But for our purposes, for our introductory graph, let's keep it simple and stay at this level of pi over 4s. So the first thing we're going to do is make a table of values. And where we do the x-axis, the x values are going to be the angles. So let's start from 0. So on this side we're going to look from 0 to 2 pi like we were just seeing on the unit circle. So if I went halfway, that's going to be pi. So let's go ahead and put pi right here. Okay, that's the same thing as what I did right here. Now if I go half of that, then that's my pi over 2. Okay, and so just like I did before, I've got my pi over 2. So this is like 1 pi over 2, 2 pi over 2, and this would be my 3 pi over 2 right here. Alright, so I'm doing the same thing that I did on the unit circle, but I'm just stretching it out horizontally so I can make a table of values. And just like we did on the unit circle, if I go halfway to pi over 2, that's pi over 4. So that's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. And going in the negative direction, it's going to be the same thing, just only negative. So we'll have negative pi and negative pi over 2 and negative 3 pi over 2, and my negative pi over 4s as well. Now let's talk about the value of the sine function at each one of these angles. The coordinates will help us do the pi over 2s, the multiples of pi over 2. So right here we have 0, 0. Up top, this point right here is 0, 1. Over here on the left, we have negative 1, 0. And down here at the bottom, we have 0, negative 1. Now remember that on the unit circle, the sine function is the y value. So this is the value of sine, and this is sine, and this is sine, and this is sine. So these are the values of the sine function at each one of these angles. Okay, so at 0, the sine function is 0. Okay, so at 0, the value of sine is 0. At pi over 2, we're up here at 1. And then at pi, the y value is back to 0 again. So it went up and came down to 0. Alright, and then how about 3 pi over 2? At 3 pi over 2, the sine function has dropped to -1. And then 2 pi. At 2 pi, we're back to where we started from. We're back to a y value of 0. Okay? And going in the opposite direction, it's just going to be the mirror image. If I went to the negative direction, this would be negative pi over 2, and I'd have -1. Let me just redraw it. In the negative direction, so I'd have negative pi over 2 here, and then this would be negative pi, and then this would be negative 3 pi over 2, and then back to the beginning I'd have negative 2 pi. Now the y value here, and I'll just do the y value, of course is -1 right here. Here the y value is 0, okay, because it's right on the x-axis. Up here the y value is 1, and then here the y value is back to 0 again. Alright, so it's going to be -1, 0, +1, 0. So -1, 0, +1, then back to 0. Now let's talk about the pi over 4s, the multiples of pi over 4. We've memorized the sine of pi over 4. The sine of pi over 4 is 1 over radical 2, or you could write radical 2 over 2, which is the same thing, but 1 over radical 2. Okay, that's the way I'm going to write it for today. So at pi over 4, we're talking about 1 over radical 2. Now, all of these multiples of pi over 4 are going to have some version of 1 over radical 2. It's just that some of these will be positive and some of them will be negative. But they will all involve 1 over radical 2. So pi over 4, the sine function is positive because sine is the y value and it's above the x-axis. Over here, 3 pi over 4, it's also going to be positive 1 over radical 2. Alright, for the same reason. It's above the x-axis. It's positive. Okay, so that one's going to be still positive. But at 5 pi over 4, now my 1 over radical 2 is going to be a negative because the y value is negative down here below the x-axis. And same thing with my 7 pi over 4. My 1 over radical 2 will be a negative 1 over radical 2 because we're down below the x-axis. Okay, so these two will be negative here and here. Now, looking in the negative direction, remember, going clockwise, I have my negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4, negative 6 pi over 4, negative 7 pi over 4, and negative 8 pi over 4 is the same thing as negative 2 pi. So again, the reference angle is pi over 4 for all of these. So all of these, the value of the sine function is going to involve 1 over radical 2 for all of these. Okay, 1 over radical 2 all the way around. Alright, it's just that 2 of these will be positive and 2 will be negative. Of course, the 2 that are up above the x-axis will be positive. The 2 that are low, alright, because the sine function is the y value, the 2 that are below the x-axis will be negative. Okay, so my negative ones will be at negative pi over 4 and negative 3 pi over 4. So there they are. These other 2 will be positive. Alright, so now that we have all of our x values and our y values, okay, so we're going to treat the angles here as our x-axis. Oh, why does it move when I do that? Alright, we're going to treat the angles as our x-axis and the sine values as our y-axis. Okay, so what you want to do is label your axis, and I'll just start over here. We're going all the way to 2 pi. Alright, so start by putting 2 pi all the way over here on the right, and all the way over here on the left will be negative 2 pi. So then just sort of estimate halfway, and you know that's going to be pi. Okay, same thing over here, I'll have negative pi. Now if I split each of those in half, I'm going to get pi over 2. Actually, let me keep that black. So halfway right here, I'm going to have my pi over 2, and this will be my 3 pi over 2. Okay, and this will be negative pi over 2 and negative 3 pi over 2. Alright, now if we split those in half, that'll be our pi over 4s. So this will be pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Okay, and let's do the same thing on the negative side. Okay, to do our scale on the y-axis, alright, so we have our x-axis and our y-axis. It's useful to look and see what's the highest number and what's the lowest number that we reach. So looking at these values, I see 0, 1 over radical 2. Well, how big is that? Anyway, 1 over radical 2 as a decimal, how big is that? Alright, I just put it in my calculator, and 1 over radical 2 is approximately 0.7. Okay, so it's more than half. So 1 is the biggest number that we have, and negative 1 is going to be the lowest number that we have. So let's use that to help us on our y-axis. So let's go ahead and put 1 as the highest number here, and negative 1 will be the lowest number. Okay? That means 0.5 would be here and negative 0.5 would be here. So let's go back and graph what we have. So at 0, the sine function was at 0. So we can mark that. I'm just going to do all the multiples of pi over 2 first. So at pi over 2, we were at 1. So at pi over 2, we're up here at 1. And then at pi, we came back down to 0. Okay, and then at 3 pi over 2, we dropped to negative 1. Alright, and then at 2 pi, we were back to 0 again. Okay, so you can see the pattern that's happening. It's rising, and then it's falling, and then it's rising again. Now in between here, all of these are radical 2 over 2 or negative radical 2 over 2. That means they will be 0.7 or negative 0.7. So here at pi over 4, that's going to be your 0.7. And this is another 0.7. And here it's going to be negative 0.7 and another negative 0.7. Alright, so that just gives you a better view of what's happening. Okay, so this is not the prettiest graph in the world, but it should look something like that. Now let's do the negative side quickly. We see at negative pi over 2 we are at negative 1, so that's going to be down here. And then at negative pi we are at 0, so that's going to be right here. And then at negative 3 pi over 2 we're up at 1. And then at negative 2 pi we're back down to 0. So you can kind of see what's happening here as this pattern that began in the positive side just continues to repeat. Okay, and once again all of these 1 over radical 2's are just going to be positive or negative 0.7. Okay, so this is going to be a negative 0.7, and this is also a negative 0.7, and we'll have a positive 0.7 and another positive 0.7. Alright, so again, not the prettiest graph I've ever done, but you get the idea. So this is basically what your sine function is going to look like over this, over this interval. Understand that we could keep going. I could go to 3 pi, 4 pi, 5 pi. This pattern will just continue up, down, up, down, up and down forever in both directions, never stopping. Alright, now it's time to do the cosine function. I went into great detail and I did the sine function very slowly so you could understand. Hopefully you can, having learned from how I did the sine function, I'm going to do the cosine function very rapidly because it's almost the same thing. So cosine now. So first of all, looking at the multiples of pi over 2, at the quadrants, the quadrantal angles. The cosine is the x value of the point on the unit circle. So this is cosine, this is cosine, this is cosine, and this is cosine. Alright, so the cosine values, looking only at the quadrantal angles, are 0, 0. That's what's messing me up. Did I really put 0, 0 here before? You guys just let me do that? Why didn't somebody tell me I was messing up? This is 1, 0, clearly. So the cosine values are going to be 1, 0, negative 1, 0. Alright, so starting here at 0 we have 1 and then 0, and then we had negative 1 and then 0, and then it goes back to 1 again. Going in the negative direction, alright, I'm starting off from the 1 that I already have. Then after that it's going 0, negative 1, 0, and then back to 1. So 0, negative 1, 0. 0, negative 1, 0, and then back to 1. Now the blue angles were all multiples of pi over 4. So since the reference angle is pi over 4, once again all of the blue angles for the cosine will involve the value of 1 over radical 2, because the cosine of pi over 4 is 1 over radical 2. But half of these will be negative, so it's just a matter of which ones are negative and which ones are positive. Alright, let's look at the positive direction first. Remember that cosine is the x value on the unit circle. So that means to the right of the y-axis, we will have positive cosine values. So these two will be positive. But to the left of the y-axis, over here, these values will be negative. So these are the two that will be negative. So the 3 pi over 4 and the 5 pi over 4 will be negative. Okay, so cosine function. So the 3 pi over 4 and the 5 pi over 4 will be negative. For the same reason, these two values, these two cosine values will be negative. So cosine will be negative here and here. All right, again, on the left side, x values are negative. So that's negative 3 pi over 4 and negative 5 pi over 4. Okay, so here's at negative 3 pi over 4 and negative 5 pi over 4. So all that's left is to plot these points, looking at the angle and their cosine value. Alright, there's our 2 pi and our pi, our 1, our negative 1, our negative pi, and our negative 2 pi. I'll split it up a little bit more. Alright, so there's that next level of detail. And there's your multiples of pi over 4. So now let's just plot some points. Alright, let's do the quadrantal angles first, shown here in black. Now notice that the cosine function does not start off at 0, 0 like the sine function does. The cosine starts off at 1. Alright, so that very first point is going to be way up here on the y-axis. Okay, and then I'll go from there. Okay, so we had 1, and then it goes 0, negative 1, 0, 1. So it's going to go 0, negative 1, 0, 1. Alright, in the other direction, it goes 0, negative 1, 0, 1. Alright, I put some lines in here to help me. Okay, so we go down to 0, and then negative 1, then back to 0, and then back to 1. Alright, so you can sort of visualize what's happening here. It's going down, and then back up again, and then to the left it's falling, and then rising again. Alright, so let's get the pi over 4s in between. Alright, looking at the blue ones, notice how they go positive, negative, negative, positive. So there's the positive, negative, negative, and then back to positive. Okay, so a little bit more detail on the graph. Okay, and over here it's going negative, negative, positive, positive. Whoops, I was looking at the wrong one. Over here it's going positive, negative, negative, positive. So there's my positive, negative, negative, positive. And again, these are approximately 0.7. Positive 0.7 and negative 0.7 is the value of 1 over radical 2. Alright, so you can see what the cosine function is doing. Alright, forgive me for my crooked drawing here. It's very difficult to draw a smooth line with a mechanical electronic pen here. Anyway, you can get the idea of how the cosine is going. And again, it would continue this pattern on, down and up forever in both directions. Forever. Down, up, down, up, down, up. And that, my friends, is how you graph the sine function and the cosine function.